Hi everyone, I'm Felipe Zurita. I'm the producer and I'm a guide of La Silla. Welcome to the new virtual tour of La Silla online. Sorry for the troubles. We have a few troubles with the stream program. So we start the tour guide of Observatory La Silla. Um, if you want, you can leave the comments in a chat box. Later, we can answer the question you leave. And we have four viewers today. I'm studying astronomy in University of La Serena. I have 33 years old, and we start explaining what is the ESO. So ready to start. Let me. The ESO is a international organization about 16 countries all around the Europe, and Chile is a home partner. Uh, Australia and Brazil is strategic members. So the ESO, the principal function of ESO is build, operating, and maintain the great machines of called telescopes or observatories. The the old observatories of ESO is here in Chile. Let me show you the facilities of this park. We have a four principal observatories in Chile. The first one, and in Chile around the decade of the 60s, is La Silla. La Silla have a 3.6-meter telescope, and ATT, the 3.6 is a exoplanet searcher. And the other is a NTT telescope. The new technologic telescope is the first telescope you have a new technology for the new telescopes. It's the father of directly of Paranal. Paranal is in the north of Chile, around the Antofagasta, in near of the ocean, Pacific Oceans, and have the Bale T, the very large telescope, and BST the Vista. Later, we built the Citia South, and in the in the front of that we have the mountain of Armazones. So let me leave with the guide today is Hernan Julio. Hi Hernan Julio, how are you?
Hi, how are you? Well,
Oh,
good.
fine.
Hello, everyone. Hello, everyone. Um, well, yes, we are. We now we are. We are. My name is Hernan Julio, and I'm a journalist specialized in astronomy. We're going to start with last. Today we have La Silla Observatory virtual visit, and I think that the best way to know La Silla is to go to La Silla virtually, of course. So I want to remind you that you can put your comments and your greetings in the chat and YouTube chat or in Facebook chat, and all your questions are welcome, of course. Let's go. Let's go to La Silla Observatory. We will fly to La Silla Observatory right now to find out where is. First of all, our starting point is in Europe. We will cross the ocean, the Atlantic Ocean, to go to South America. Okay, the 16 countries that Felipe was showing you are part of ESO, plus Australia, which is is our strategic country, and also Chile, which is the host country. And now we are going to the host country right now. We are crossing the ocean in order to go to the to South America. Why ESO decide? Well, ESO decides to build this telescope in Chile because we have the driest desert in the world. First of all, in the 60s, they start to look for a place in the southern hemisphere where to build telescopes, big telescope. They look for in Australia. They also look in Africa, and then Chile. And they found out this desert, the Atacama Desert, which is the driest desert in the world. Now we are flying to the middle part of the country, Chile, crossing the Andes Mountain, and we will go right where La Silla Observatory is. Here you are. And now, yes, we will make a flyover La Silla. La Silla Observatory has about 14 domes, okay, with different telescopes. You're looking at the Danish telescope, 1.54 meter in diameter. The extra, those are very new. There's like around the balls telescope. They're looking for extrasolar planets. The ESO 2.2 meters, which now is then we have the 1 meter Schmidt camera. Most of these telescopes are robotics. That means that nobody works inside in the night, and they are operated by in remote control from a different part of the world. We have this radio telescope, and we have the 3.6, the 3.6, which is in the top of the mountain right there. We have a smaller telescope like the Swedish telescope, the Swiss telescope 1.2, and the 3.6 meter telescope. Okay, so this is an overview of La Silla Observatory, which is about 500 kilometers north from 600 kilometers, from Santiago de Chile, which is the capital of the country. Let me take you around the. Let me see. Here we go. Okay. Here, let me give you a panoramic view of La Silla. Okay, we're looking to the west right now. In this area, in 2019, July 2nd, 2019, was the total solar eclipse in this area in Chile. And here we have 1,000 people, okay? 1,000 people looking to the ocean, looking to the west, where the sun was having this total eclipse. Here you can see now we are going to go around, and here we have the CEST. CEST is the radio telescope, submillimetric telescope, Swedish ESO submillimetric telescope. Now it's out of order, okay, because most of the people that used to work here went to work to ALMA, the Atacama Large Millimetric Array, the biggest radio telescope in the world. We will talk a little bit about that later. And here we are looking to the east, to the mountains, okay, to the Andes Mountains, and you can see how these gorgeous colors of the sunset go over the mountains. And here, of course, what we're gonna do is to visit the 3.6, the inside of the telescope. Here we are. You will see in this panoramic view also, this 360 degrees view, how big it is. Okay, this is the dome. The dome is about 350 tons. Okay, the telescope is the light blue part. The dark blue part is the mountain, the mount, the mount, and the mount is an equatorial mount. And down there we have a man, we have a person, okay, an engineer, of course, I think. And you can see how big is the telescope. You can have this this view here, how it is. Well, how does this work? Well, at night we have to open a window, okay? We open this window in order to let the light coming inside the mirror, okay? Because the telescope today, they work with the mirror. Here we have the 3.6 meter telescope, means that the mirror that I'm showing here, this round thing, light blue thing, round thing that you see, is the mirror. Inside is the mirror, okay? The mirror is curved, okay? And so the light will come in the night to the main mirror, will be reflected to the secondary mirror here, okay? And from the secondary mirror goes back again down to the instrument, which used to be in this cage down there, okay? over here is the instrument. The instrument, what is an instrument? The instrument is a camera who detect the light, okay, capture the light and send that information to the instrument, okay. In this case, the instrument that we have is the HARP. HARP is a very special instrument. It's called an extrasolar planet finder, looking for planets around other stars. In this case, the HARP is not inside of the cage because it's so special that it needs to be, the instrument, the HARP, needs to be in the third floor, in a sort of a vacuum, okay, where the temperature cannot change, okay. In that way, the instrument works perfect. And what does the instrument? What HARP does? I think we have a Felipe. We have, there we go. We have a video to show that. Well, HARP is detecting planets around the star. How he does that? Well, we cannot see the planet because the light of the planet, the light that the planet is reflecting from the star, is very thin. Very deep, very dim. So what we do is look to the light of the star, and the light of the star, using the Doppler effect, can tell us how this star is getting close to us a little bit and how go far away from us. Why the star come close to us and go a little bit far away? We're talking that it's impossible to detect without a very accurate instrument, which is HARP. Why does that? Because the gravity, the planet around the star will pull the star, so we will see that movement of the star, like that the star is going away or going close to us. That's called radio velocity technique. That way, HARP can know if there is a planet around the star. Okay, so that's the way how we detect planet. That's the way how astronomers has detect about 5,000 planets around other stars. Not only with this technique, there is several others, like, for example, the eclipse technique, where we wait for the planet go in front of the star and see how the light of the star dims a little bit. But the one that we use here with HARP is this radio velocity technique. All right, let's continue. One other thing that you should know about this telescope was inaugurated in 1976. So it's a classic telescope, okay, and the mount is an equatorial mount. We will go to see another telescope, the other main telescope that we operate, the ESO operates in La Silla, which is the NTT, and you will see the difference. Okay, I don't know if there is any question, any greetings from our friends.
Nothing until nothing question. You remember, viewers, you can leave the questions, greetings, everything you want to know about the astronomy, the telescopes, everything you know about the space, the objects, celestial objects. Whatever you need, we try to answer the question.
Yeah, or just let us know from where you are looking at from around the world. We would love to know from where you're looking at us today, because the traffic of the very high traffic in internet, the application didn't let us start on time, but we're a few minutes late, and we will continue then to visiting La Silla in this virtual tour. Here we're back at La Silla, the outside, okay, and I want to show you the next telescope, which is the NTT. This is a very special telescope, the New Technology Telescope. Here you are, the New Technology Telescope, as you see. Okay, it's very different in the way that it's built. The building is in a square building, very different from the building that we just saw in the 3.6. The telescope also looks like it's a little smaller. The telescope itself is all this white part, and that's why. Why is that? Because the mirror. Let's take a closer look to the mirror. There we have the mirror. The mirror is a special mirror. Was made with a special ceramic. It's called Zero Dur, okay, low expansion. ceramic. The Cerodur allow us now. Before the Cerodur, we only could make 4-meter diameter mirrors. With Cerodur, we can go up to 8 meters. Okay, this mirror, the one that you're looking at, is 3.58. Okay, almost 3.6, same the one that we already look at it. Uh, However, we don't need a so big mount, dome, okay, because the mirror is flexible, okay, it's thinner, and it's not so much so heavy. The mirror also has we use a new technology in the mirror we call active optic. The mirror, as you can see, is curved, okay. This curve, we when we use the mirror in the night, the telescope in the night, the curve of the mirror could change a little bit, okay. We what we do with active optic, we correct that imperfection in the mirror, which is underneath the mirror. You can see this actuators. There's a little actuator there. That's like let's say like that. This actuator push up the mirror in order to keep always the surface perfect. In that way, we always have, while we're observing at night on real time, a perfect mirror. That means that the light will go to the main mirror. Okay, we open the telescope or the dome, as you see now, the enclosure is open in the middle, right at the half of it. We open this, and the light will go to the main mirror, will be reflected to the secondary mirror up here. The secondary mirror send the light back to the mirror in the center. And there in the center, okay, we have a third mirror. Okay, this is very special. A flat 45 centimeters diameter mirror, and will send that light to the right, or will send the light to the left. Okay, the mirror is in 45 degrees, and we can move it in order to send the light to the right or to the left. Why we do that? Because behind this door, right here, there's a door and there's a room where is the instrument. The instrument in this case is not underneath the mirror, it's at the side. Okay, Nasmith A or Nasmith B, which we call is the way that we call the places where we put the instruments. Okay, and what is an instrument? An instrument is, as you saw with HARP, it's an instrument who will detect the light of the star, and not only will detect but also will analyze. Okay, we make a spectrum. This spectrum will tell us what kind of element has the star that is sending the light, how much hydrogen, how much calcium, whatever. Okay, so with this analysis, we will know what type of star, what type of object that we are looking at. That's why the instrument is very important. Okay, and we have different instruments. We have instruments that work at visible. Visible means that light that you can see, light as we see with our own eyes. Okay, and also we have instrument we call infrared instrument, where this instrument will detect light, but it's a different light. It's called infrared, and infrared is hot, it's warmness. So we will detect that the warmness of the object that we are looking at. This is very important because there is a object that are behind, for example, a big cloud of gas and dust, and we cannot see what is behind, but we can detect the hot of that, the warmness of that instrument, of that object. Well, the other thing to say is that in the night, this as I show you, this as you can see, this building is very different from what we saw before. Over there is the 3.6 where we were, but this one rotates in 360 degrees. Okay, this is this building, the NTT building, rotates while it's observing. How come? As you know, that the stars at night, they move. Well, they don't move, we move. You know, the rotations, Earth rotations, rotation movements make looks like that the stars moving. Well, we have to follow the stars. Okay, so we point to the star, We point the star that we want to observe, and then the whole building will rotate, following the star for 5 minutes, 3 minutes, 1 hour, whatever the astronomer needs. Okay, I think about us. We're talking about the astronomer. Where are the astronomers? Well, the astronomers
This
are
is a
in
commonly
the control
question.
room. Excuse me.
Yes, this is a commonly question. Where work the astronomer? Here's.
There we go. Now we're looking at a video, okay, of where the astronomer work at night. Okay, you can see at your right, you will see the what we call control room, uh, the 3.6 control room. And to the left, you will see the NTT control room. It's just one big room. We call the control room, La Silla control room. And the astronomer, we have usually two people working at the control rooms. One is the telescope instrument operator, is the one who point the telescope, move the telescope, check that all that the telescope is pointing where it have to point in the sky, in the universe. And we have the astronomer. The astronomer will make sure that the information, the data, is the scientific data that he needs. So usually it's a very, as you see, they are very busy all night long. Of course, we keep all the windows in the back. In the background, you can see how the blackouts of the window are closed in order to not let any light to go outside. We are very careful of not having light going outside in the night to the sky, because we have a precious sky and the stars. We're saving the stars in order to not pollute the star with light produced by humans. Well, about that, I want to show you something that if you come to Chile, you can take a look at this sky. Now, I will be able to show you the sky over La Silla, because actually, usually we cannot. I mean, when you come to visit at La Silla, by the way, we have open doors for visitors every Saturday and Sundays at 10 o'clock in the morning, from April to August. And from September to March, we have open doors every Saturdays at 10 a.m. and 2 p.m. Okay. Unfortunately, in those visits, you cannot stay after 5 p.m., so you will not see this sky from La Silla Observatory, but you can to the go down and go to the desert, and you will see this gorgeous, gorgeous sky. Okay, let's see what we have. Well, first, let's talk about a little bit about something that maybe our guest today can know. Is this constellation is a typical northern constellation. Here we see it upside down is Orion. Okay, Orion is a man, is a hunter. Okay, these three stars here are the Orion belt. Okay, and you can see here that we have a shoulder. Over here we have another shoulders. Here is the head, and back here we have one leg, and we have another leg, and here is the sword. Okay, and just to see how great is the sky for to take pictures. Well, this is a picture taken by a camera. Okay, nobody a telescope, for a regular camera, professional regular camera. I mean. And here I can show you the Orion Nebula. Okay, the Orion Nebula is amazing. You can see it with the small telescopes. Well, here you can see with a picture for a long time exposure pictures. This nebula, in this nebula, are burning thousands of stars. It's a burning place for stars. You can see it there easily. Also, here we have this constellation. Here is the big dog. Okay, Canis Majoris, and this is the eye of the dog. Sirius, one of the most bright star in the night. Well, that is a little bit for those that are from the northern hemisphere, that you can see from the northern hemispheres too. But this is the Milky Way. Okay, this is our Milky Way, how we see it from the southern hemisphere. Okay, and here we go. Okay, and the first thing that we can see in this gorgeous sky are the Magallanes cloud. These two clouds here, which are not clouds, they are galaxies. These galaxies were discovered by Magallanes. That's why we call it Magallanes. Magallanes was a navigator. Yes, he came down. He crossed the Ecuador in his ships and in the southern sea, and he looked to the star up in the star, and was a different sky. Okay, you know that when you cross the southern, you cross the Ecuador, the stars, the constellation, the sky change. Okay, and he found out this too, and these are, he thought these were clouds, but we now know that they are galaxies. There are two galaxies, the closest galaxies to us, and there are two satellite galaxies. They are going around our own galaxies. Okay, the Great Magallanes Cloud and the Small Magallanes Cloud. And Magallanes also find out that he could find the south. I mean, he could navigate with these clouds. How? Well, he found out that he could make a triangle with these two, and in this point of in this angle of the triangle right here, this third angle of the triangle, he found out that that was the southern celestial pole. What is the southern celestial pole? Well, it's the point where all the star goes around at night. Okay. Also, I can show you that a typical constellation, the southern constellation, which is the Southern Cross. There you go. This is the Southern Cross, okay? And you can also use, just in case you come to Chile and you get lost, you can use the Magallanes Cloud at 9 or the Southern Cross to find out the south. Let's do how we do that. Well, we take the long stick of the cross. This is the longest stick of the cross. This is the other stick of the cross. You take the long one and go 1, 2, 3.5, and you will get right in the same point, in the same angle of the triangle that Magallanes used to use to find the southern celestial pole. What is important about the southern celestial pole? Because if you find the southern celestial pole, you make a line to the ground and you will have the south. Okay, so there we're looking to the south. That's why we know that we're looking to the south. This point is the same point that you have in the northern sky, in the northern hemisphere, and you have the polar star. We don't have any bright star in that point. That's why we use the Magallanes Cloud or the Southern Cross in order to find the place. Okay, so how you see, this is a gorgeous sky, but also let you know that we used to have our own people, our original people from the Andes. They were very great astronomers too. Actually, very near to Silla, we have an archaeological site where we have about 1,000 stones who show how these people used to look to the sky. Actually, they have constellations. They have constellations, for example, but not the constellation that we used to have, where we see the point of light. The night or the sky for them was so bright that they could see very well this dark spot in the Milky Way. Okay, this dark spot in the Milky Ways for them were the constellation. Here, for example, you follow me with this dark spot here. You use your imagination, you can see a llama. Actually, it's called the llama constellation. Here you are. This is the neck, the head, and actually, this star here is the Alpha Centauris, which is the eye of the llama. They also have this another one, which is the Bear constellation, and also the snake constellation down here, and so on. Because for them, the Milky Way was a river where all this animal, the animal of their daily life, went down to drink water. Okay, so it's beautiful that today, 2,000 years after these great astronomers, this great Andes astronomer, today, 2,000 years, we have new astronomers from all over the world in La Silla Observatory looking to the sky. Well, I think we're running out of time very quickly. I don't know if there is any questions.
Greetings, Heavens. This is beautiful. I wish I could have my ashes scattered here. Say, this is a beautiful place to end your life. Oh, incredible, say Ellie. And I have a video about the 10 principal discover from ESO, discovered from celestial objects and principals investigations. So I let me put the video and see the top 10 of ESO discovers.
All right, let's go to see it.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when two independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
This is the
Right.
top 10. Remember, you can visit the observatory, right, Hernan?
Yes, well, this is one of the most important things that we want to mention. Yes, you can visit the observatory every Saturday, as I told you before, from every Saturday and Sunday between April and August at 10 o'clock in the morning. You can online, you can make your reservation online if you're coming to Chile. And from September to March, you can do it every Saturday at 10 o'clock and 2 p.m. Okay, we will be glad to have you with us and show you all this observatory. The visit is free, and you just have to come and with your own transportation to the bottom of this hill, and from there we have a bus who will take you from the bottom of the hill to the observatory. We will go around the observatory and show you the telescopes, and also we have a visitor center where we will give you a talk about astronomy. We have a couple rooms, museum rooms, talking about what has been all these years of astronomy. Remember that ESO has 60 years already in Chile. ESO arrives in Chile in 1963. Last year we have 60 years of ESO in Chile, and La Silla was the first observatory that ESO built in Chile. We will go down already to have a coffee. We will invite all of you to have a coffee. We will walk around this observatory. Remember also that you can visit us in ESO.org, ESO.org organization, and you will be able to use the same picture. We have this 360 degrees tour is online. You can use it. You can visit. We are showing you. We have we have only 1 hour. We cannot show you all the pictures that we have. Also, there is thousands of pictures, thousands of videos, astronomy videos about discoveries, about the stars, and everything that you can use and freely use for yourself or for education. So here we are walking through the observatory, and we can see some of the light pollution. This is what we are fighting in Chile against, too. Light pollution. Cities around the telescope of the observatories have to use a very special lighting. Also, they have to light the light in a special way. We have to light the ground and not the sky. That's what we say here. So if you come to Chile, we will thank you if you keep that in mind in order to not pollute the stars, this beautiful star, the beautiful sky that we're looking at it. And the nearest city from La Silla is Vallenar, which is not a big city yet, but it's growing up, and also La Serena, which is a little farther, an hour or 150 kilometers from La Silla. So we're trying to avoid this light pollute our sky. All right. Actually, here we can see also again the Orion Nebula, the Orion Nebula and Orion. Okay, let's have a coffee now. Okay, coffee break with our friend. He is the one who make possible this 360 degrees tour. He took the photographer who took the pictures, and you can see this gorgeous sky over his head. Maybe we can remind you that we have this ESO webpage where you can, of course, visit and you can see the latest new with us. Now, I don't know if there is last questions or last comments.
Today, the people only greeting say thank you, thank you for you for view the tour virtual tour. But in the next week, you can leave the question, everything question about astronomy or the telescope of La Silla or Paranal.
Yeah.
Every Saturday have a virtual tour.
Yeah, it's very well to know that every Saturday at 11 a.m., we have this virtual tour of La Silla and Paraná. Also, they are in English and Spanish. Today was La Silla in Spanish. Next week, I think it's Paraná in English or Spanish. I don't remember. But we will wait for you. And please visit us, okay? We also we will be pleased for you if you are planning to come to Chile to visit us. You can book online and you will be with us every Saturday. We have a great team of guides that will show you the telescopes, they will show you the observatory around, and these gorgeous mountains, this gorgeous place where we are. Remember, we are in La Silla Observatory, which is a little city. This is a little scientific city in the Andes Mountains. So you are welcome, and hopefully we'll see you in next week at 11 again, the next Saturday at 11 in the Paranal Virtual Observatory tour. Also, we invite you to follow us in our social media, in Facebook, in YouTube, astronomy, ESO astronomy in English, and YouTube, where we always posting. If you have any question, okay, if you follow us in Facebook astronomy, in ESO astronomy, if you have any question, you can make it through our Facebook page, and there is people who will answer those questions to you. So you're welcome to come back in this tour, virtual tour, to come to Chile and visit us in La Silla and Paraná, and also, of course, take this tour again every Saturday. We have Lestec. We say hello to Lestec. We say thank you very much for those nice information. I will definitely visit this so soon in times you mentioned. Great. We will be waiting for you. Thank you very much for your visit, and we will see you next time online or right here in the observatory on the ESO observatories. Thank you very much for attending this tour. See
So
you next
bye bye.